This is a Sudoku called Magic Gym by Coloin. You can read more about it in the comments to this video. I've said on this channel that these ultra-difficult Sudokus are works of art, and this one is a real masterpiece. It begins with several simple solves that enable us to fill in much of that upper left block. This also allows us to recognize several places where a given number can only go in two squares. I've explained on this channel how helpful that is for solving. We can also recognize some other places already inherent in the puzzle where a given number can only go in two squares. You need to keep in mind that the 4 can go in those two squares. But what filling in those numbers in the upper left-hand block does that's even more significant is that it creates a situation where the numbers 1, 2, and 3 are the only ones that can go in the highlighted blocks. So we should be very interested in that middle block. And we recognize that one possibility is to place the 1, 2, and 3 in different columns and different rows. The thing is, if they're in that position, it's always going to lead to a contradiction. Let me illustrate that. Some number has to go in that cell. A different number needs to go in that cell. In this cell, it could be that same different number or the other number, the 1, 2, or 3. Doesn't really matter what the A, B, and C represent. This determines what's going to be in that cell. So the only other choice we need to make is whether that first number is going to go in one of the two cells shown here. Let me use one possible set of choices as an illustration. From the information we have, we can fill in all the other numbers. And what we discover is that the A and C can't go there, and the A and C can't go there. So the two of them have to try to fit in one cell, which of course is impossible. Well, let me illustrate that using another possibility. Here's another way to set up that middle block. So the 1, 2, and 3 are in different rows and columns. Here's an entirely different set of choices that we could make. But once again, we have the same result. The A and the B have to go in the same cell. So it's very helpful to know that in the middle block, the blanks cannot be in different rows and different columns. So we know that these shaded cells have to be 1s, 2s, or 3s, and at the lower right we have a 1 and a 2. It'd be good to find a 3 if we could. And this cell is a good place to start looking because it can be only a 3 or an 8. Well, suppose it's an 8. Then we know that the 1, 2, and the 3 go in the middle, and this allows us to find more places where a given number can go in only one of two cells. We also find places where a given number can only go in one of 4 cells. And this shows that there are only 2 possibilities for that bottom block. If the 9 is with the 7, then the 6 is with the 5, and the 8 is with the 4. But the result is that pattern where the 1, 2, and 3 are in different rows and columns, which we know always leads to a contradiction. The only other possibility is if the 9 is with the 4, that puts the 8 with the 5 and the 6 with the 7. But once again, it leads to a pattern where the 1, 2, and 3 are in different rows and columns. So we can conclude that the number in that cell is not an 8, it must be a 3. This allows us to fill in some more information. And it shows us what numbers must be in that bottom block in terms of being only in 2 cells or only in 4 cells. And once again, we can look at all the possible combinations. If the 9's with the 4, the 5 must be with the 3 and the 6 with the 7. But this leads to that same impossible situation. So the 9 must be with the 7, and one possibility is the 6 with the 5 and the 4 with the 3. But that also leads to an impossible situation. So the 9 must be with the 7, the 6 with the 3, and the 4 with the 5, and this must be the setup in that middle block. Once we know that, we can recognize that in this row, the numbers 1, 2, and 3 must go in these 3 cells. That allows us to fill in some information in the center right-hand block. It also leads us to a very interesting discovery. There must be 2 different numbers in that top row there. Let's represent them this way. What we can show is that whatever two numbers are in those cells are also in these two cells. For example, suppose the 1 and the 2 are there. Then the 1 and the 2 must be there. Suppose the 2 and the 3 are there. Then the 2 and the 3 must be there. Or if the 1 and the 3 are there, the 1 and 3 must there. So we can be confident that whatever numbers are in those two cells on top are also in the two cells in this column. This allows us to fill in some further values. We can see that the 4 and the 9 must be there. We can also see that the third number, whatever it is, must be in that top cell because neither the 1 nor the 2 nor the 3 can go in the bottom cells. This allows us to fill in the 4, 6, and this shows us that the 4 must be in one of those bottom two cells. Perhaps most importantly, it shows us that the third number, whatever it is, has to be with the 8 there. This shows us that in this cell, we must have the same two numbers that are on top, and it shows us that the third number goes with the 8 on the bottom as well. And this is enough information for us to discover what C is. Suppose, for example, it's a 1. This leads to a contradiction. Well, suppose it's a 2. This also leads to a contradiction. So the C must be a 3. This also enables us to know that A and B are 1 and 2. We can discover further that since in this column the only other available cell is either a 1 or a 2, that must be a 1 or 2 there up top, and we can start filling in our 3's. We can fill in all of the 3's, in fact, and this enables us to fill in the rest of the 1's and the 2's. Now there's enough information out there for us to decide where the 1's go and where the 2's go. For example, suppose that number there is a 1. Leads to a contradiction. So that number must be a 2. And that enables us to fill in all the other 1's and 2's. It shows us where they are in the bottom row. And this enables us to fill in the numbers there based on the information we already have. And from here, it's not hard to use the information that we have to fill in the rest of the grid. And there it is, the solution to Magic Jim.